Good morning, students. Today we'll do a new theory which is called valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. In short form, it is called VSEPR theory, VSEPR theory. Valence shell electron pair repulsion theory. This is one of the important theory in chemical bonding chapter, and this is one of the theory by which you can find out the actual structure of a molecule. As you have got hybridization concept, from hybridization you can explain the structure. If some molecule undergo sp3 hybridization, then the structure will be tetrahedral. If some molecule undergo sp2 hybridization, it becomes triangular planar. And if some atom in molecule shows sp hybridization, the structure will be linear, bond angle will be 180 degree. So you can find out the structure and bond angle of different molecule by applying the concept of hybridization. But it is found that there are some molecule, for example water, H2O. In water, the central atom is oxygen, and oxygen undergo sp3 hybridization. If you apply the formula whatever I have given, then you will get it. Oxygen shows sp3 hybridization. Since oxygen shows sp3 hybridization, that is why oxygen water structure should be tetrahedral, bond angle should be 109.5 degree. But it is found that the bond angle in water is 104 degree only, not 109.5 degree. So why the bond angle is less? So you can explain it by applying this valence shell electron pair repulsion theory. And you know, to become a tetrahedral structure, there must be 4 bonds present. By applying 4 bonds, you can make the tetrahedral shape, tetrahedral structure. But as you know, in water, only 2 bonds are present with oxygen. So by applying 2 bonds, how to make the tetrahedral shape? And that is the drawback of that hybridization concept. And you can explain properly about the structure by applying this valence shell electron pair repulsion theory, in short form, which is called VSEPR theory. Now what is this theory? The electron pair means maybe bonding electron pair, maybe lone pair. The electron pairs surrounding the central atom, the electron pair surrounding the central atom, they can repel each other, they can repel one another, and that is why they always try to move far away from one another. And due to this interelectronic repulsion between the electron pairs, the molecule will adopt a new shape, and the bond will remain on that position in which the repulsion will be minimum 1. And from that concept you can find out the shape of the molecule. For example, if you consider beryllium chloride, BeCl2 molecule, then you can understand something. In beryllium chloride, you know beryllium, its atomic number is 4. I mean it contains 2 valence electron. When beryllium chloride is produced, beryllium contains 2 electron, and there are 2 chlorine, one chlorine I write here, another chlorine here, and chlorine contains 7 electrons in the valence shell like this. 1, 2, 3, 4, 5, 6, 7. Now sharing of electron takes place. After sharing, they produce the bond between beryllium and chlorine. But here beryllium, although it do not complete the octet, I mean although there is no there has no 8 electrons, but beryllium can produce the compound like this way. Actually there are some compound in which the central atom cannot complete the octet, but although it cannot complete octet, it can form the molecule. Now after formation of the bond, when you draw the beryllium chloride structure, someone can draw beryllium chloride like this, someone can draw beryllium chloride like this, someone can draw beryllium chloride like this way also. Now when you draw different structure, then the angle, here angle is this much, here angle is this much, here angle is this much, I mean you will get different bond angle. But a molecule always have a definite bond angle, so you should maintain that. So who will be the actual structure? To find out that, you can find out this one by applying valence shell electron pair repulsion theory. So what about this theory? In beryllium, always you look about the central atom. No need to see the surrounding atom. First you look the central atom. Our central atom is beryllium, and beryllium, this side one bonding electron pair, this side one bonding electron pair, and there is no lone pair inside beryllium. These are called bond pair electron. So now when you draw the structure like this is your bond pair electron, these are your bond pair electron. So when they are close to each other, then this bond pair and this bond pair, they can repel one another. And when the repulsion takes place between bond pair, then the bond will move far away from one another. And when they move far away from one another, then at what position the repulsion will be minimum one? I mean, the bond will take a position in which they become far away from one another. And that is why in case of beryllium chloride, the bond goes like this way. I mean, angle will be 180 degree, so that the bond pair become repulsion become minimum one. But when you draw like this, the bond pair is very much closer, then repulsion will be more, and when repulsion is more, the molecule will be unstable, and that is why automatically the bond will far away from one another, so that the repulsion become minimum one. And that is why beryllium chloride always adopt linear shape with angle 180 degree. Similarly, in some molecule, the central atom contain lone pair also, then repulsion takes place between lone pair and bond pair also. Then also you will get different shape. So this was said by your valence shell electron pair repulsion theory. I mean, inside the central atom, number of electron pairs may be present. It may be lone pair, it may be bond pair. So due to this inter-electronic repulsion, I mean the repulsion between the electron pairs, the molecules become unstable, and that is why it will adopt a shape in which the repulsions between the electron pairs are minimum one. And from that concept, you have to find out the original shape of the molecule. So according to this theory, the electron pairs surrounding the central atom, they repel one another, and due to this repulsion, they are far away from one another, they are far apart from one another, so that no further repulsion will take place between them, so that the molecule will get minimum energy and maximum stability. So when the repulsion is minimum, energy will be less and the molecule will get the maximum stability. But when the repulsion is going on, then the molecule have very high energy. Ultimately the molecule will be unstable. It cannot stay for a long time. So that is why every molecule try to get the stable form, and when it will get the stable form, when there will be less repulsion inside the electron pairs. So by applying this concept, you can find out the shape of different molecules. In water, as I have told you, in water oxygen undergo sp3 hybridization. That's why the shape of water molecules should be tetrahedral. But you know, in water, the central atom oxygen carrying some lone pair of electron. There are two lone pairs present inside oxygen, and due to presence of the lone pair, your oxygen, water contain two single bond, and there are two lone pairs present inside oxygen. And due to presence of lone pair, this lone pair and this lone pair, they undergo repulsion. And due to this lone pair repulsion, the bond will come closer like this, so that the repulsion is minimum. And that is why in water, the bond come like this way, and the angle you will get 104 degree. Actually, since oxygen shows sp3, the angle should be 109.5 degree. But due to this lone pair repulsion, initially it was 109.5 degree. But due to lone pair repulsion, the bond come closer. And due to closeness of the bond, the angle going on decreasing. How much decreasing? 5 degree going on decreasing. I mean, from 109, it becomes 104 degree. It is only due to presence of lone pair, due to lone pair repulsion. So that is why a central atom may contain some bond pair, may contain some lone pair, and due to this electron pair repulsion, the molecule will adopt a new shape. And that is why when the bond come closer like this, ultimately the shape of the water goes to band shape like this, like V shape. So that is why angle also you will get different as you have got from the hybridization concept. So now I'll give you number of molecules, how many lone pair, how many bond pair present inside the central atom. Based on that, you can find out the structure of the molecule. Thank you.